Hello and welcome. In this video, we'll talk about dividing polynomials. There are two different methods that we will focus on, and we'll start with the long division since it is a method you have learned since elementary school. We're going to get started with a very simple example and try to divide 144 by 2. So first we have to write the number 144, brackets, 2, straight line. And then we have to check and see how many times number 2 goes into the first digit. So 2 is a single digit number. So 2 goes into 1 on 0 times. So that means that we need to focus on, or we have to stretch to 14. So 2 goes into 14 7 times. So we'll say that 7 will be the first digit of the quotient. So 7 times 2, 14. And we'll subtract 14. We have 14 minus 14, 0. And then bring number 4 down. Number 2 now goes into number 4 2 times. And 2 times 2 is 4. And subtract 4. We get nothing in here. So we're going to say that the division has been completed. And the quotient, or the answer, is 72. The denominator is 2. And the numerator is 144. Now, if we want to write the numerator in terms of the quotient and the denominator, then we'll say that the numerator, 144, equals the quotient, 72, times the denominator, 2. Now we're going to take a look at another example. So we're dividing 145 by 2 this time. 2 goes into 14 7 times. 7 times 2, 14. Bring 5 down. 2 goes into 5 2 times. 2 times 2, 4. And 5 minus 4, 1. So this time we divided number 145 by 2. And as an answer we got number 72 and a remainder of 1. So the quotient, we're going to say 72. Denominator is 2. Numerator 145. And this time we have a remainder of 2. Now, if we want to write the numerator in terms of the quotient and the denominator, then we'll say that 145 is equal to the quotient, 72, multiplied by the denominator, 2, adding number 1. Now, in polynomial division, we practically do a similar thing, but we introduce some newer ways of describing our terms or our numbers, because we don't have just numbers, we have terms, and that will alter in a way or slightly the process of division. So in polynomial division, the numerator is called the dividend, and the symbol that is more commonly used is px. The denominator is called the divisor, and the symbol used is dx. The quotient is called simply a quotient again. And the symbol we use is qx. And the remainder is indicated by the symbol rx. Now, I'm going to draw your attention again to this division in here. And what we are going to do is divide every term, or in the equation here, by 2. So we can say that 145 divided by 2 equals 72 plus 1 over 2. So in other words, we're going to say that 145, which is the dividend, px, divided by 2, which is the divisor, is equal to the quotient, qx, plus the remainder divided by the divisor. Or in other words, px equals dx times qx plus rx. The reason I'm pointing out at it is because this is a very important statement that you will be asked to write whenever you perform a division. And we call this the division statement, which describes the relationship between the dividend, quotient, remainder, and the divisor. Okay, so remember that in polynomial division, one of the things that we will more commonly do is stating restrictions. And that's because in polynomial division, our divisors will be in polynomial form, so they will be made of terms rather than just numbers. So we're going to practice together how to find restrictions, something that you've done in grade 11. In this case, we're going to say x cannot equal 0. Remember, restrictions are the values of x that can make the denominator 0. So x minus 3 can be 0 if x equals 3. So we're going to say x minus 3 has to be different than 0, which makes x different than 3. So x different than 3 is the restriction. So in the next example, we need to write this divisor into factored form. So that would be plus 3 and plus 4. And we'll say that x plus 3 cannot equal 0. And x plus 4 also cannot equal 0. Which tells us that x cannot equal negative 3 or negative 4. So the restrictions will be negative 3 and negative 4 in this case. And here the restriction is x different than positive 3, and here we have x different than 0. So we're going to get started now with the exciting part of the lesson, so performing a long division. So first thing first, we write the dividend, which is our polynomial expression. Now it is very important that when we write the dividend, we write the terms from highest to lowest degree. And then here goes the division by x minus 3. And right here is where the quotient will go. Now, in polynomial division, what we have in here is 2 terms in the divisor. And it can be more than 2 terms as well. So we'll probably see some examples together. And the idea behind the division is that we simplify the first term in the dividend. And in order to do this, we focus first only on the first term of the divisor and the first term of the dividend, and see how many times the first term of divisor goes into the first term of the dividend. Or in other words, how many times does x go into 3x cubed? Now this can be a little bit awkward for us to figure out right away, but I want to bring you the example we just did before, 145 divided by 2. So when we were trying to figure out how many times number 2 goes into 14, we very quickly said that, well, that's 7. And then 7 times 2, 14. Now, when we work with numbers, it's quite intuitive because we're so used to them, and numbers are much easier to master. But when it comes to variables or to terms, it can be a little bit more difficult, but not that difficult. Now, think about it this way. So the way you figure out the number of times number 2 goes into 14 is by simply dividing number 14 by 2. So 14 divided by 2 is 7. And that's why we say that 2 goes into 14 7 times. The reason I'm bringing this example is because The same operation that you perform to figure out how many times a number goes into another is used in polynomial division. So in this case, if we want to figure out how many times x goes into 3x cubed, we simply have to divide 3x cubed by x. And we know that 3x cubed divided by x is 3x to the power of 2. So again, as I mentioned, we are going to focus on the first terms first. And we're going to say 3x squared is the number of times x goes into 3x cubed. So what we're going to do is, actually, I'm going to use a different color here. So what we are going to do now is multiply number 7 by 2, right? That's what we did, and write the answer here. So the same thing, 3x squared will be multiplied now by x minus 3, because this whole thing is the divisor. So 3x squared will be multiplied by x minus 3. And from this multiplication, we'll have 3x cubed and then minus 9x squared. We're going to draw the line again, and we're going to do the exact same thing we did in the division of 145 by 2. So we'll subtract 3x squared minus 9x, sorry about that, from the polynomial 3x cubed minus 5x squared minus 7x minus 1. So 3x cubed minus 3x cubed is 0x cubed. Negative 5x squared minus negative 9x squared, careful here, is positive 4x squared. Now it's time to bring down the next term. The next term is 7x negative. And the strategy will be the same again. So we have to figure out how many times x will go into the first term of the polynomial. So x goes into 4x squared, 4x times. So we'll write 4x in here. And then we'll multiply 4x by x minus 3 again. Now 4x times x is 4x squared. See how we are kind of making each term disappear, but everything goes in order. And 4x times negative 3, negative 12x. Draw the line again. And now we'll subtract 4x squared minus 12x from 4x squared minus 7x. Now 4x squared minus 4x squared is 0x squared. Negative 7x minus negative 12x is positive 5x. Now it's time to bring down the last term, negative 1. And again, same thing. We're left with 5x minus 1 here. So we have to check and see how many times x goes into 5x. X goes into 5x. 5x over x 5 times. So we're going to write 5 in here. And right here we're going to multiply number 5 by x minus 3, so our quotient. So 5 times x is 5x. 5 times negative 3 is negative 15. We'll draw the line again, and we'll subtract 5x minus 5x, 0x. Negative 1 minus negative 15 is positive 14. Now the next thing you want to look at is if you have any more terms left. Obviously we don't. And we can check if x goes into 14. It doesn't. Okay. And we're going to stop our working here, and would say that we're ready to make or to write a division statement. So I'm going to say that the polynomial px is 3x cubed minus 5x squared minus 7x minus 1. Our divisor dx is x minus 3. We obtain the quotient qx, 3x squared plus 4x plus 5, and the remainder is 14. In our case is a constant number. Okay, so if we were asked to write a division statement, so I'm just going to highlight them, then we're going to say that px, which is the dividend, 3x cubed minus 5x squared minus 7x minus 1, divided by the divisor x minus 3, equals the quotient, which is 3x squared plus 4x plus 5, plus the remainder of 14, which still has to be divided by x minus 3. And what we just wrote in here is the division statement for the long division that we just performed. Okay, so in a similar way we are going to divide or perform the next division. So as you see in here, we have negative 19x squared, so x squared term first, x cubed second, and then x and constant. So what we are going to do is rewrite the polynomial in order, so pay attention there. So 6x cubed must be the first term. The next term must be an x squared, and then the x term, and then minus 20, and we're dividing by 2x minus 5. So as we did before, so we're going to go ahead and check and see how many times 2x goes into 6x cubed. So 6x cubed divided by 2x equals 3x squared. So 3x squared. 3x squared times 2x. Sorry, here. So 3x squared will multiply 2x minus 5. And that will give 6x cubed minus 15x squared. Right here. Subtract what we got here. We're going to say 6x cubed minus 6x cubed, 0x cubed. Negative 19x squared minus negative 15x squared is minus 4x squared. And then we'll bring down 18x. Same thing again. We're going to check and see how many times 2x goes into negative 4x squared. So negative 4x squared divided by 2x is negative 2x. So negative 2x times, we'll take negative 2x divided by 2x minus 5. And we'll say negative 2x times 2x, negative 4x squared. Negative 2x times negative 5 is plus 10x. Draw the line and subtract. And we get 0x squared. 18 minus 10x is 18x minus 10x is positive 8x. Time to bring down our last term here. which is minus 20. And again, we have to check and see how many times 2x goes into 8x. And you notice that as we go, or as we practice, it becomes a bit tedious to repeat the same operations that were probably a bit harder to figure out at the beginning. And that's what math is about. So you have to practice a lot, because the more you practice, the more the faster things will make sense and connect. So we're going to say that 4 times, or 2x into 8x, and we're multiplying now 4 by 2x minus 5, and that will give 8x and negative 20. Here, draw the line again, and then take away 8x minus 20, and we have 8x minus 8x, 0x, negative 20 minus negative 20. Oh, that's 0. So we have no remainder here. So the question is also asking to write the answer in the statement, or to write the statement division, and that's what we're going to do. Remember that our px is the dividend, so we'll say 6x cubed minus 19x squared plus 18x minus 20 divided by our quotient in the, here, our divisor, right? Here is 2x minus 5 equals the quotient. Here goes the quotient, the answer, in other words, 3x squared minus 2x plus 4, and then plus no remainder, so 0. So this will be the division statement in our case. And let me box this up. And this was one very ugly box. Here we go. So I hope that at this point in time we have gained a little bit of confidence in how to follow the process of long division in polynomials. And I want you to practice this on your own, and I am going to try to do this a little bit faster than in the previous examples. But feel free to stop the video and practice this on your own. So again, we are taking care of the terms, placing them in order. 6x cubed minus 4x squared minus 9x minus 3 be divided by 2x squared minus 3. Now notice how in this case the divisor is second degree, and second degree polynomial expressions can have a maximum of 3 terms. So we have an x squared term, we don't have an x term, but we do have a constant. So what I like to do usually is write the divisor in this form. The reason why I want to do it is because sometimes it's easy to miss the x term and misplace the numbers when you perform the division here. So I'll show you as we go over the solution together. So again, we are going to take a look at the first term in the divisor and the first term in the polynomial, or the dividend. And we'll say that 6x cubed divided by 2x squared equals 3x. So 3x times. And now we go 3x. That multiplies 2x squared plus 0x minus 3. So that would be 6x cubed plus 0x squared minus 9x. Now, Notice or remember how I said that it's better to write the x term, because what happens often when people forget to write this, they go ahead and multiply 3x by -3 and place the -9x in here. Now we want to list the terms in order so it's easier for us to subtract. And you know that we can always subtract the like terms, okay? So 9x cannot go in here. So it's not just cosmetics, but we are trying to avoid making a mistake by placing things in order, in other words. So we're going to subtract what we got here. And we have 6x cubed minus 6x cubed, 0x cubed. So x cubed term is gone. Negative 4x squared minus 0x squared is negative 4x squared. Negative 9x minus 9x is 0x. It is what it is. And we're going to bring negative 3 down. Again, same drill. We're going to check and see how many times 2x squared goes into negative 4x squared. And negative 4x squared divided by 2x squared equals negative 2. So it goes negative 2 times. And here we go again. We go negative 2 multiplying 2x squared plus 0x minus 3. And we have negative 2 times 2x squared, negative 4x squared. Negative 2 times 0x is plus or minus 0x. Okay, it doesn't really matter. Negative 2 times negative 3 is positive 6. Draw the line. Subtract. And we have negative 4x squared minus negative 4x squared, 0x squared. Notice how the first term in a subtraction always ends up being 0, because it works that way. 0x minus 0x is 0x. And negative 6 minus 6 is negative 9. So we're going to identify here the dividend. All right. So the dividend is this expression here. And we're going to say that the dividend px is 6x cubed minus 4x squared minus 9x minus 3. And now it's time to identify the divisor. This is the divisor. So we'll write dx equals 2x squared minus 3. And now we have to identify the quotient. The quotient is always the answer. So qx equals 3x minus 2. And last but not least, we have to identify the remainder, which is, in our case, rx equals negative 9. And since we're here, let's write the division statement. So remember, the division statement is px over dx equals qx plus rx over dx. Now, it may be a little bit awkward to memorize this, and I'm not a big fan of memorizing things. But I do want you to understand and whenever needed, produce this formula. So this is my way of remembering this division statement. So if you were to divide number 7 by number 2, then you would say that that's 3 1/2. Okay? So this is your dividend and this is your divisor. That's your answer. And this will be your divisor again, which is dividing your remainder right here. So if I forget this formula, I always follow this very simple division. 7 over 2 equals 3 plus 1/2. And then I adjust it to the polynomial division. So here we go. We have 6x cubed minus 4x squared minus 9x minus 3 divided by 2x squared minus 3. I knew I was going to make this mess here. 2x squared minus 3 equals 3x minus 2 plus negative 9, which means minus 9 divided by 2x squared minus 3. If you want to check and see whether these two sides will be exactly the same, you can go ahead and do so. You have to multiply these two together to bring under the same denominator, and you will end up having this polynomial expression in the numerator. And you can very easily see it with numbers. Numbers are easier to see. So 3 plus 1 over 2 is 3 over 1 plus 1 half, or 6 over 2 plus 1 half, or 7 over 2. So you see how this side becomes this one here. Okay? So here is our division statement, which we are going to celebrate by boxing it up. All right. So in the next question, or in the next example, what we are doing is we are taking the polynomial division a little bit further, and we are trying to figure out a missing coefficient when we know what the remainder is. So let's get started. So we can do this together. Obviously, you can always try on your own. It's totally fine. So I would consider this as a thinking question. And I would prefer that we go over the thinking process together. Again, feel free to stop the video and try to think about the answer on your own. I know you can do this. It's nothing too difficult. So here we go, x6. We do not have an x5 term, so I'm going to write 0x5. We do have an x4 term. No x cubed, so 0x cubed minus 2x squared, and then plus k. This is being divided by x squared plus 0x plus 1. And here is our spot for our quotient. What we do know is the fact that, oops, sorry about that. What we do know is the fact that the remainder is 5. So we have to go all the way to the end of the division and then figure out what this missing coefficient here is. This number here is, okay? So let's get started. And whenever you are solving a problem that you've never solved before, do not try to fathom how difficult it can be, but try to think, what is one step that I am able to do? What's the first step? Or is there anything that I can take or I can consider as a first step? So baby steps take you far, far in your learning. So x squared goes into x6, x to the power of 4 times. And here we go, x to the power of 4 will multiply x squared plus 0x plus 1. So that will give x to the 6, 0x to the 5, and then plus 1x to the 4. We'll draw the line here, and we will subtract this. So here we go again. x6 minus x6 is 0x to the power of 6. 0x5 minus 0x5 is 0x to the power of 5. x4 minus x4, great, 0x to the power of 4. So we have nothing left in here. We are going to bring down the rest of the terms. So we have the term 0x to the power of 3. This is not helping. So since we don't have any terms left in here, we're going to bring down the next term, negative 2x to the power of 2. And we're also going to bring the k term here. And by the way, I just noticed that we need an extra term in here, the x term. So 0x and then plus k. Sorry about that. And we have to bring 0x as well, and then k. Now, why can we do this? Like in other examples, we only brought down one term at a time, okay? So we can do this because in this case, we have 3 terms in the divisor, right? So 3 different degree terms, right? So it's totally fine to bring down the rest of the expression. It doesn't really confuse your solution or messes up it doesn't mess up your solution. So we're going to say that we have x squared, right? And we are going to check and see how many times it goes into negative 2x squared. So we'll say x squared goes into negative 2x squared negative 2 times. Okay, so we don't have to actually reach out for this coefficient, and don't let this unknown confuse you. Always think next step, next step. And that's the only answer we can put in here. So negative 2 will multiply x squared plus 0x plus 1. So that will give negative 2x squared, negative 0x, and then negative 2. We'll draw the line here, and we will subtract. And we have negative 2x squared minus negative 2x squared equals 0x squared. We expected this to happen. 0x minus 0x is 0x. And then the remainder would be k minus negative 2. So the remainder k minus negative 2 can be written in a simpler form as k plus 2. So we don't know the value of the remainder based on this division. We only know that it is k plus 2. But since we're given the value of the remainder, then we can say k plus 2 must be 5. So that will make k equal to 5 minus 2. So k equals 3. Okay, and that would be the answer. So